Okay, in this week's lesson, we are going to conclude Chapter 8. We're going to use triangle proportionality theorems, and we're only going to cover the first part, 8.6. There's some other theorems that are not quite as important. Okay, so again, I'm just going to try to cover the important things these last 7 or 6 weeks of school. Okay, so notice I erased the 6.6 here, right? We're actually in 8.6. 6.6 actually corresponds to the old geometry textbook. And so if you take a look at your first theorem here, the triangle proportionality theorem basically states that if a line is parallel to one side of a triangle, intersects the other two sides, then it divides the two sides proportionally. And that's the word you want to fill in, proportionally. Okay, so notice, right, if these two lines are parallel, right, notice this intersects two sides of a triangle. If TU is parallel to QS, right, then this side right here divides this side and this side proportionally. So in other words, I could say RT is to TQ on this side right here, and RT would correspond to RU over US. Okay, so that's what it means when it says that this line divides this side and this side's proportionally. Okay, you could say RT is to RU as QT is to SU. That's another way of saying it, right? You can put the RU down here, put the TQ up here. Okay. All right, so that's the triangle proportionality theorem. And the converse is basically the opposite, right? And it reads, if a line divides two sides of a triangle proportionally, in other words, RT is to TQ as RU is to US, then it is parallel to the third side. Okay, so in other words, TU is parallel to QS. All right, so we only have really one theorem here, and let's take a look at the first example. It says in the diagram, right, QS is parallel to UT, RQ is 10, RS is 12, ST is 6. What is the side length of QU? So over here, I don't know what QU is. I'm just going to call it X. And we can just apply our triangle proportionality theorem, right, which says that if this line right here intersects two sides of the triangle and it's parallel to the third side, by our triangle proportionality theorem, right, RQ is to QU as RS is to ST. Okay, so I'm just going to write it out. RQ is to QU as RS is to ST. And what we're trying to solve for here is X. And now all you have is a cross multiplication problem. Okay, so fill in the values. You're going to have 10 over X is 12 is to 6. You're going to get 60 when you cross multiply right here is equal to 12X. And X is just equal to 5, which is the length of QU. Okay, so moving on to our second example. A spoiler for a remote control car is shown where AB is 31, BC is 19, CD is 27, DE is 23 millimeters. Explain why BD is not parallel to AE. Okay, so this is some spoiler right at the end of a car, towards the trunk of a car. And what you can do right here is maybe redraw that triangle and label it so we can make it a little bit bigger here. We'll call it C, B, A, and then D, E. Okay, and then of course label it, right? CD is 27, DE is 23, BC is 19, and BA or AB is 31. Okay, so they're basically saying, explain why BD is not parallel to AE. Okay, in order for BD to be parallel to AE, right, by the converse of our triangle proportionality theorem, right, basically the sides right here have to be divided proportionally to these sides right here. Okay, so we have to check CD is to DE as CB is to BA, right? If they are proportionally divided by this third side right here that intersects these two sides, then we can say, hey, by the triangle proportionality theorem converse, this side's parallel to this side. Okay, now clearly when you plug in the numbers, right, 27 over 23, question mark, CB over BA, these guys clearly don't equal, right? 27 over 23, right? That's 1 and 4 over 23, right? 19 over 31, that's about 0.5 something, okay? So you can say, I guess you could just say, hey, these sides are not proportional to each other, therefore not parallel, okay? Use the parallel symbol there. And that's pretty much it, right? Your checkpoint right here, you can practice these problems, but let's just go over it, right? Find the length of KL. Again, I'm just going to call this X. These two sides are parallel, right? Based on the parallel symbol, you can just say X is to 18 as 44 is to 24. When you cross multiply and solve, 24x is equal to 44 times 18. Divide by 24, you're going to get x is 23, so that would be KL. And this last problem right here, right, is again applying the converse of the triangle proportionality theorem. I have to determine if QT is parallel to RS, and I don't just look at it, right, I have to set a proportion. Does 36 over 80 equal 18 is to 38? In other words, does PT over TS, question mark, equal PQ over QR? Okay, and let's just reduce these fractions here. Clearly, I could divide by 4 on top and bottom. You're going to get 9 over 20. Divide by 2 for both these values to reduce our fraction. 9 over 19 clearly does not equal 9 over 20. Okay, so I can say QT is not parallel to RS, right? Since PT over TS does not equal PQ over QR. Okay, so this would actually be a better explanation. Basically you can write the same explanation over here. You can say, hey, this is not parallel, DB is not parallel to EA since CD over DE does not equal CB over BA.